Hello guys, welcome to mathematical lesson for grade 12. We are still continuing with the same topic, Euclidean geometry for grade 12. But now we are moving into the next part of this Euclidean geometry since we are done with proportionality theorem part and proportionality theorem where we are using multiple ratios on the lines. So now we are moving to the next part of this Euclidean geometry where we will be dealing with area ratios. So remember, I said a ratio can be something that can be represented in a fraction form. For example, let's say I'm giving you a ratio A is to B. You can write this ratio in the form of A as a numerator. The one that was on the left in your ratio is going to be the numerator on your fraction. Then the one that is on the right here on the ratio is the one that is going to be the denominator here on your fraction. So yes, you can express the ratio in a form of a fraction. Also, if you are given a fraction, you can express that fraction in the form of a ratio. Fine. Now, let's come to this area ratio. Area ratio is a ratio where you will be given the fraction, and that fraction, the numerator, is an area of a certain triangle, and the denominator is an area of a certain triangle. So that is the ratio of the areas of the area ratios. So here they are saying to us, in this section, you will learn how to calculate the ratio of the areas of two triangles under a specific condition. Okay, now at first we are given the type 1. Let's learn about type 1. What does type 1 say to us? They say same perpendicular height. So there's this one type 1 that says the same perpendicular height. We all know if we were given a triangle and you want to calculate the area of that given triangle from grade 8, if you are given a triangle like this, let's say this triangle of mine have angles or corners A, B, C. Let me label this triangle of mine A, B, and C, such that there exist a height there that is perpendicular to the length BC. And this height of mine in this triangle is H. And I'm requested to find the area of this triangle. So the area of this triangle, the area of this triangle ABC, ABC will be equal to, we know this formula, half times base times height. Okay, so now on this given triangle here, I will have my half times, what is the base of this triangle? It is BC. So, okay, I'm having BC times the height of this triangle is H. So, okay, if you are given a triangle with the height that is perpendicular to the base of this triangle, then you can simply go for this formula, area times base times height. Yes, now let's go and see what this type is saying again. So they gave us some triangle here, triangle ABC. Okay, that is a bigger triangle. We also have some triangle because they divided the bigger triangle into some two other triangles. So we also have triangle APC and triangle ABP here, we can see. But all these triangles have the same height H here because this height is perpendicular to the height. So when we just pull out these triangles out of that triangle ABC, let's pull out just a triangle APC there. A triangle APC is drawn like this. This is our height H that is perpendicular to base PC. There is our A there. It's like this. And then we go for triangle ABP. It's something like this. It's something like this. And then we have our height here that is perpendicular to the base. Okay, this is our base and then our height. So even if our height is like this, it is outside this triangle as long as it is perpendicular to the floor of this triangle. We still can go for that formula that says an area of that triangle is equal to half times base times height. Okay, now let's have a look on these formulas that they gave us. Okay, the first formula is this one. Is the ratio of area of a triangle ABP. ABP all over area of triangle ACP. ACP. Okay, fine. Let's say now this numerator, we will have an orange triangle. It's ABP. It's ABP. Here it is. Okay. Then we go for another triangle. This one ACP. I will throw it in blue color. ACP is this one. So we want the ratio of the area of this triangle. What is the area of the triangle that is orange? The triangle ABP. ABP is this one with the base BP with the height H. So, okay, we will have half times the base of that orange triangle, which is BP. We have BP times height H times height H. Okay, now we go for the denominator, which is the area of triangle ACP. ACP is this one. Then we are going to have our half times the base of this blue triangle is PC. Okay, we have our PC as the base times the height of the triangle is H. There we are given. Now, half and half, they cancel each other on this fraction. And the height will cancel out each other. Now we will be left with only BP over PC as the ratio. So this is the ratio of the areas of this triangle. It's BP over PC. Okay, we are done with this one. We can go for the next one. Now for this one, we are given the formula for the area of ABP again. Okay, the orange one, ABP all over ABC now. Okay, ABC, let me continue with my color blue. Okay, so ABC is the blue one, is ABC there. Okay, so ABP, we know, is going to be 1 over 2 times the base of ABP is BP times the height H. There we go. Okay, all over. Now, what is the area of the triangle ABC? This is triangle ABC. It's going to be the half times the base of this triangle, the blue one, ABC. So the base of that triangle is BC. We can see it. Then we have our base times height. The height of triangle ABC is H. So the height of that triangle is H. We substitute our H there. Then again, this half will cancel out with that half. This height will cancel out with that height. Okay, fine. Now we are left with BP over BC. Now, the ratio of the area of this triangle ABP over the area of triangle ABC is given as BP over BC. Now we are done with this one. Again, we go to the next one, where we are required to find the area of the triangle ACP. ACP, okay, let me go erase and have another colors. Let me use lemon. ACP is this one right here. It's ACP. Now we can move to the next one, which is ABC. I will use another different color for that one. Maybe, let me choose, oh, orange. for this one, ABC. So ABC will have this triangle. This is triangle for ABC. Fine. This triangle, we are still going to use the same approach for these ones. We have the height there for these triangles. So let's go for ACP. This is ACP. What is the base for that one? It is PC. That is the base. So what is the formula to calculate the area of this triangle? It's half times base times height. So we have half times base, which is PC, times h, which is the height of the triangle. All over, now we come to ABC, which is the orange one. Now, still we are using half times base times height. So I'm sorry a little bit. Let me do this. Right. Okay, I'm sorry for that. Now, like I was saying, we are here on the area of the triangle ABC. ABC have got the base BC and the height H there. Okay, so we will use the same approach. Area is equal to half times base times height. So the base of the orange triangle is BC and the height is H. Now H will cancel out with the H, half will cancel out with the H. Now we are left with the ratio PC all over BC. That ratio represents the area of the triangle ACP and the area of the triangle ABC. Okay, so now this is what we can just use from get-go. If you are given the triangles and you want the ratio of the areas of those triangles, and you can see that those triangles have got the same height, then you can just say the ratio of those areas of those triangles is equal to the ratio of their bases, just like that. And now we can go for type 2, where they say the common angle and parallel lines. Common angle and parallel lines. As we can see on this diagram, we've got triangle ABC, and then there exists a line PQ such that the line PQ, excuse me, is parallel to the line or the third side of the triangle BC. So now, this one is going to require you to know how to use an area rule. So just to remind you guys on how area rule works, given this triangle, A, B, C, like this, and then there is an angle theta there, and then you want to find the area of this orange triangle here. So area rule works like this. If you want the area of that triangle, area of triangle ABC, that is equal to 1/2 times these two sides, and note that these two sides meet there at the angle. They meet here. So we take AB times BC. We take AB times BC times sine of the angle theta there. This is how an area rule works, guys. So, okay, now let's go and apply this area rule there on this area ratio areas, however you can call it. Now we are given this triangle ABC such that PQ is parallel to BC. Now they here give us the formula of to calculate of calculating the area of the triangle APQ. APQ, here is APQ. This is our APQ. Okay. And then this is our ABC. This is our ABC. Now, the area that is on top is area of APQ. This is APQ, the one that is on the bottom, ABC. And we can see that all these triangles that I've highlighted here, they share an angle A there. That's the only thing that is common between these two triangles. So now let's use area rule. So once you see that the areas that form your ratios, they share a same corner or same angle somewhere, then you will definitely have to go for an area rule ratio. So for this one, let's first go for area rule for that orange triangle APQ there. Now to use it, we will have 1 over 2 times those sides that meet there at the angle, which is AP times AQ. AP times AQ times sine of the angle there at A. Okay, now we come to the denominator. We will have 1 over 2 times those two sides that meet at the angle, which is this one and this one. So in this case, it will be AB times AC times sine of the angle that was between those sides, which is sine A. Now is equal to this half cancel out with the half, the sine A cancel out with the sine A. Now we will be left with the product AP times AQ all over AB times AC, just like that. So now they say to us, let me erase this, they say to us, but AP over AB, where is AP? This is AP all over AB is equal to AQ all over AC. Why? Because that is the line, there is a line parallel to the side of a triangle, or you can say proportionality theorem. Why? Because there is PQ parallel to BC. Okay, now this wants to show us something. Since this over this is equal to this over this, now you can just take one ratio PQ, just like they did here, you square it. Yes, you can just say the area of triangle APQ all over the area of triangle ABC is equal to AP over AB, everything squared. Or you will choose to work with this side, AQ over AC, everything squared. Then you are done with type 2, where they say the ratio of the area, as long as the triangles in that ratios share the same angle, then that ratio will be equal to the ratio of corresponding side squared. Corresponding side, or ratio of corresponding side squared. Yes, I hope this makes sense, but just to ensure that you guys are comfortable with what I just said, let's just have a look on this example 12 here, where I only will have a look on the first two, A and B. I will explain this A and B, emphasizing what we just talked about there on top. So, example 12 says that in the sketch alongside, we are given that PQ is parallel to AC. PQ is parallel to AC. Okay, and PR here is parallel to BC. What does that mean? Proportionality theorem applies. Okay, if proportionality theorem applies, then we definitely can use that ratio that we are given there and play it around the sides of this triangle and work out something. So the ratio that we are given is for this side. BQ is something like 4, and the QC is something there like 3. Okay, Now let's see what is the question requiring us to do. So we are required to find the ratio of the area of triangle ABQ. Let me highlight that triangle ABQ. This is my ABQ. This one, okay? And okay, this is the blue one. Now let's go for the red color. It's ACQ. ACQ is this one. It's this one. Okay, fine. Okay, we had two types that we talked about, where the triangles have the same height, or the triangle have the same angle somewhere. Now let's look these two triangles, whether they have same height or same angle. We see, okay, there is no angle that is common in the two triangles, but okay, we have some height here that I can construct. Here, there can be a height that I can construct. There we go. Such that this height here is perpendicular to the floor of the base of these triangles. So we name this height of ours h. Then, okay, now this will be equal to the area of the numerator, the area of triangle ABQ. ABQ will be half times base. What is the base of the blue triangle? Is BQ. Is BQ times height. What is the height of this triangle? Is height H. I'm going to have my H there. Okay, all over half times base of the red triangle is QC times QC times the height of the red triangle is still the height H. Therefore, now we are here. This H cancel out with that H, this half cancel out with that half. Now we are left with that BQ all over QC. We are left with BQ over QC. My line here. Fine. This is equal to what is BQ? It is a 4. I have my 4 there. What is QC? It is 3 there. So now this is the ratio of this, the area of these triangles. Fine. Let's go to the next one. The next one, we are required to find the ratio of the area of triangle BPQ. Okay, let me go highlight the triangles. Let me erase. Okay, we keep in mind that we still have the ratio this side. That is 4 here and 3 here. Okay, now let me go back to my colors. Blue, BPQ. BPQ is this one, okay, and ABQ. ABQ, I'll use red, ABQ. ABQ is this one. ABQ is this one. Okay, now we go back to our types there of this ratio of areas. Whether this is the type where we have the common angle between the two triangles, or we have the same height between these two triangles. So, okay, we can see that we either can use this as the common height of as the common angle of these triangles, or you can use the height that is perpendicular to the base or bases of this triangle, the height h there. It's up to you which method you are using. You will still get the same answer. So now, what is the base of the triangle BPQ? The base of BPQ is going to be PB. So it's going to be PB all over the base of triangle ABQ. ABQ is going to be AB, AB, just like that. then you go like this. Now, who knows what is that side, or what is the length of that side, or what is the ratio of that side, PB and AB? We don't know. But now, since this line is parallel to that line, then proportionality theorem applies. Now, is applicable. We can just say this over this is equal to that over that using proportionality theorem. Okay, now we say PP over maybe PA, you can do it like this. PB is this one, or VP is equal to this side, BQ, all over QC. QC. Why do we say this? It's because we used proportionality theorem. Why proportionality theorem? Because PQ is parallel to AC. Fine. Now let's make our substitutions. BP over PA is equal to, what was this? What was BQ? It was 4. What was QC? It was 3. Fine. Now we can come substitute our things here. What is PB? It is 4. We can see there, you put your 4 there. Then what is AB? AB we can see is from here to here, meaning AB is equal to AP plus BP or PB. PB, that is equal to, what is AP? Here, AP is 3 plus PB is 4. Now everything is 7. So my AB there will be 7. So there we go. So the reason I didn't substitute my times half here, I mean my height here, and my half and my height, my half here, is because we were still going to cancel them out as we proceed with this part. So it's just best if you understand that you are going to use the type 1 where we have got the areas of these triangles with the same height. Those heights will cancel out each other and the halves will cancel out each other. We will end up being left with the ratio of only the bases. So that is why I just decided to write PB over AB as my answer. Then our answer is 4 over 7, just like that. Then you will use those types that we talked about there to use to do these other two problems. Now we can go to the next part, which is the last part of these this area ratios. So where we are having the triangles between parallel lines. What are we having after this part? Oh, it's exercises, then afterwards it's similarity. So, okay, triangles between parallel lines. So when we are having a look on this thing, we have parallel lines here. ADP is parallel to the line BCQR. And then there exists some triangles between these parallel lines. This triangle ABC is between those parallel lines. And this triangle DBC is between lines. And this triangle PQR is between those parallel lines. So let's see what they are saying here. They are saying triangles with the same base or equal bases. Fine. And those triangles are between the same parallel lines, have the same area or have equal areas. So we can see that triangle ABC and triangle DBC have the same base here, this base BC. And these two triangles are between these parallel lines here. What does that imply? That tells us that the triangle ABC and triangle DBC have the same area. Okay, we are also given again that BC is equal to QR. indication, it was indicated by these lines that this BC is equal to QR. And again, this triangle PQR is between these parallel lines. What does that imply? That implies that these triangles have got the same area as these two triangles here. Yes. Now, here we are having the area of the triangle ABC. ABC is equal to the area of triangle DBC. DBC is equal to the area of triangle PQR. What is the reason behind that equality that we are talking about there? Is same base, the same height. Because we have the same basis there and the same height h there between these parallel lines. I hope this makes sense. So now let's see how we can apply this one on some examples here. Okay, here they are saying to us, we are given the sketch alongside such that the line AE is parallel to BD. Okay, and then we are given the ratio ED here. ED is 5. Okay, and DC there, it is 12. Okay, now let's see what we are required to find and how can we play around our ratio to find something. Oh, we are required to find the area of the triangle ABD. ABD. This is ABD. Okay. And another triangle that is on the bottom of the denominator is BDC. BDC is this one. BDC. It's this one here. Yes, there we go. So now they are saying to us, notice that the triangle EBD, where is EBD? EBD is this one, and the triangle ABD, have the same base BD. This is the base that they share. Oh, and they're between parallel lines and lie between parallel lines, and thus they will have the same area. Okay, this triangle and this triangle. So let me draw this here, and then where this blue line overlaps that red line is where they share this same base BD, and they lie between these two parallel lines BD and AE. Thus, they will have the same areas according to this thing that we're having here, the triangles between parallel lines. Okay, now this means that we can calculate the area of EBD all over BDC. BDC, this one. How can we do that? Now, having a look on these blue triangles, do we have anything common? No, but we can have some height there that is perpendicular to the basis. Now, we will say the area of this triangle EBD all over the triangle BDC will be equal to just the ratio of the bases. What is the base of EBD? EBD is going to be ED all over the base of BDC. BDC, the base of that is going to be DC. DC. Therefore, my ED is 5 over DC is 12. Okay. Now, what are we going to do when we are here? We just substitute this triangle EBD. EBD here by which triangle? By ABD, because this triangle and this triangle have got the same areas. So now this ratio will be the same as this ratio. Just like that, you will be done calculating what you are required to do. I hope what we just went through will make sense to everyone, guys. By the way, this lesson will end here. I will see you guys on the next lesson. Bye bye.